Hi, my name is Amin Ajmi, and today I'm going to be presenting the Smart IoT Parking System project. We are actually a group of three, and our group is composed of Emmanuel Aguboshim, Amin Ajmi, myself, and Mohammed Hamami. So, let's go ahead and start with the motivation of our project. So, actually, this project is based on the idea that the Internet of Things has the possibility of remotely monitoring and analyzing recorded data. With this idea, we wish to exploit this technology over a Wi-Fi range to monitor the inflow and outflow of vehicles within a certain parking area. The monitored and recorded data is transmitted as TCP packets with valid timestamps onto an IoT cloud server. And in our case, we are using the Ubidots cloud server. So let's move ahead and present the hardware and software setup. So this project is mainly based on the Arduino Wi-Fi pretzel board, to which we added some sensors and actuators to achieve certain functionalities. Yeah, for example, we added the LEDs to show a visual state of the parking space. We also added the 7-segment display to give a more specific visual display of the parking capacity. And finally, the ER sensors, which are set up to detect the entering and exiting of the cars. So the coding part was mainly done on the Arduino IDE, and the resulting data was sent to the Ubidots cloud server using AT commands over TCP packages, and it was also stored and analyzed there. So let's move ahead and present the block diagram. So actually the data sensing stage all through the processing and transmission stage for this project can be represented with 4 blocks. So as we can see on the block diagram, a sensing system is enacted which consists primarily of the 2ER optical avoidance sensor, which uses normally the light of sight reflection from its target, which is in our case the vehicles. So the reflected signals are read into the Arduino pretzel board as digital pulses, which are then further processed on the Arduino itself based on our algorithm and code. So these are mainly stored in the sketch we have developed for this project, which is composed of several lines of codes which enable mainly the connection to any Wi-Fi network within a range. So this feature was done actually using the AT commands, which were used to enable and sustain those features. And these commands were also used to enable connectivity and process data transmission as well as reception from and to the Ubidots IoT cloud server. So yeah, the Ubidots IoT cloud platform was the place where we transferred our data, we received it, and then analyzed it. So the main results were finally displayed on the IoT GUI as well as the 7-segment LED and the LEDs locally placed on the pretzel board. And with the appropriate controls, we also enabled actuated signals and notifications via SMS, email, and LED indicator to signal full parking capacity to the users. Now let's take a look at the Ubidots dashboard that we designed for our application. So, as you can see, the dashboard is composed of several widgets, and each of them represent a specific information about the state of the parking lot. So, on the upper right, you can see the parking capacity slider. And actually, we set this up because we want our parking system to be more flexible. This means whenever you have a problem in your parking space, let's say, for example, construction works, then you can change the parking capacity, you can take it up and take it down, or you want, for example, to enlarge your parking, then you can do that using the slider. To achieve this functionality, we used the get function from the Ubidots. So we managed not only to send data from the Arduino to the Ubidots, but also to get data from the Ubidot itself and send it to the Arduino. So the second widget on our dashboard is set up to show the available parking spots. And with that, you can visualize the available or free parking spots in real time. So the next widget is the number of entry cars, and this one is set up to keep track of the number of entry cars as a summary. As you can see on the dashboard, the same thing is done for the exiting cars. And just below those two widgets, we keep track of the history of the entering and exiting cars. So we can see when car entered and exited the parking lot with a timestamp and a date. So the next widget signals the last value of parking state, and this gives the information of how many cars are already in the parking space in real time. And with these values we make charts that gives us information about the flow of cars in the parking lot. So you can see when the parking is too empty or too full, and you can manage to set up the opening hours, for example, or just to get an idea about the inflow outflow of cars in the parking lot. And finally, the green widget on the right is set up to keep the average of the parking state. So we also made some notification events to notify the user when the parking is already full. When that happens, the user gets notified with an SMS and also an email. So now let's get to the practical part and do a quick demonstration of our project. So the first thing to do is to set up the parking capacity. And let's go ahead now and set up the parking capacity to 5 cars for the purpose of this demonstration. So once done, we plug in our Arduino and wait a few seconds for the Arduino to initialize and get the parking capacity value from the UBDOT. Now you can see that the Arduino is ready to go and the number of available parking places is displayed on the 7-segment display. So the same number of available parking places is also displayed on the IoT dashboard, which is already on the screen of the computer on the background. Also, the green LED is on, which means that the parking is not yet full. Now, once a car enters the parking, it gets detected with the ER sensor. So on the same time, the 7-segment display signals the detection and the presence of a car on its screen with the inward. So yeah, as you can see, the car enters the parking and the number of available places changes immediately, which you can see on the 7-segment display and also on the IoT dashboard on the background. So just about the same thing happens when a car exits the parking. It gets detected with the ER sensor, an outward gets displayed on the 7-segment display, and the numbers will change on the 7-segment display and also on the IoT dashboard. So now let's fill up our parking and see what happens when the parking capacity gets to its maximum. Now as you can see, once the parking is full, the red LED turns on, a full word gets displayed on the 7-segment display, and as you can see on the background on the IoT dashboard, the available parking spaces is 0 and the current state of the parking is 5, which is the maximum capacity of parking places. So at this very moment, the user gets notified with an SMS and an email, as you can see on the screen, stating that there are no more available parking places in the parking lot and the parking lot has already reached its maximum capacity. So with this being said, we come to the end of this video. Thank you for your attention and I hope you enjoyed it.